All right, what we're going to do is we are going to mix some daily household items. This is dishwashing soap. This is hydrogen peroxide, the type of liquid that you put on your scrapes and cuts. Now, when I mixed these, did anything new form? Shawnee?
No, ma'am.
What happened? What can you tell me? What happened, Lincoln?
It's a physical change because they're still the exact same. They're just mixed together. Well, they didn't make a new substance.
Didn't make a new substance. Now, if we take this substance right here, this catalyst, and a catalyst is something that speeds up a change, we are going to pour it in and see if a physical change or a chemical change occurs.
Whoa.
All right, who can tell me what happens? Kaden?
The dish soap and the hydrogen peroxide, it fizz when the catalyte, we pour the catalyte in, it's starting to fizz.
All right. And was a new substance created?
No.
Okay. Why do you say that?
Because even though you are taking two things that have chemicals in them and putting them together, like all of them are not just like one chemical. Like it's actually an object that's just full of chemicals, so nothing like the texture is still the same.
Okay. All right. Thank you, Andrew. What do you think?
I would like to say that that is a chemical change because
Okay.
once it's a chemical change, I would say that because the chemicals combined when they weren't, it was a physical change first off because it was just chemicals floating around that nothing happened. But when the new substance of a chemical was combined, it made it to where it fizzed up. That was a chemical that caused the other chemicals to start.
All right. Now we know two of the ingredients in our reaction were dish soap and hydrogen peroxide. What about the third one? Do we know exactly what was in here?
Yes.
Jackson?
Water and yeast.
Water and yeast. So based on that, our soap, our dish soap, our hydrogen peroxide, our water, and our yeast, was something new created when we made that reaction? Shawnee?
The fizz that came out of the testing tube.
Okay, so that was our new chemical or new product. And we could say that it was possibly gas. So was something new created whenever we made this, Lincoln?
No. Wait.
Yes.
Hang on. Yes, it was.
Yes, so therefore would this be a chemical or a physical reaction?
Chemical.
Chemical change, a chemical reaction. Very good. So today what we're going to do is we're going to have several different experiments throughout the group and we're going to explore chemical and physical changes. So our standard that we're covering is students will explain the difference between a physical change and a chemical change. And our essential question is, how can I tell if matter has undergone a chemical change or a physical change? Now, we need to break our essential question down. We need to know, how can I tell if matter has undergone? What does undergone mean? What does undergone mean?
I don't know.
Andrea, what does undergone mean?
Undergone, I believe it means, I'm not sure, but I think it means that it's like happened.
Okay.
What is called
Jacqueline.
happened.
All right, undergone, if it's happened. Tyler?
I think it means it means when something is like it goes down.
Okay, when it goes down, if something goes down, if a chemical change goes down or a physical change goes down, we're going to have to see if the matter has changed. Noah, do you know what a physical change is?
Physical change is when it changes the appearance. It doesn't change like the substance inside of it.
Okay, can you tell me what a chemical change is, Haley?
Chemical change is when it changes. It doesn't usually.
make something new. All right, so that's what we're going to do in our different stations today. We're going to explore chemical and physical changes. We're going to get into groups. We're going to rotate through our 4 stations, and then we're going to come back together and discuss what we discussed, what we saw, and what we wrote down in our science notebooks. All right, go ahead and get into your groups.
But when you turn it on, it goes straight up.
What type of change do you think is occurring?
Physical.
Why?
Because it's still the same. It's still the same thing, but it just glows.
And also it's plugged into the wall.
You didn't know that.
And also there are still little like wire things making it turn on.
And it also looks like it's 102 years old.
And this is a surge of energy reaching into this. And we also figured that when you turn it off, it's slower
Than when you turn it on, because like when you turn it off, it stays flipped. I
Okay.
think that's just the speed of light.
Well, what has to take place for it to be a chemical change?
It has to be something different. It has to become a different chemical.
It has to change substance and you can't be able to like take it apart.
Okay, and did it?
Yeah, you can take it apart right now because that's
Careful, it'll get hot.
That's taking it apart.
My hand has been here for like 2 minutes.
And also if you put your hands on it like this, turn it off, it'll send like turn it off. It'll send like a heat wave.
When you turn it on, that's mixing it, and then when you can unmix it by turning it on.
All right. What's happening over here?
We have to rip change because we didn't change that. You have to rip trouble or do something like that, and you have to see if it's a chemical.
Okay, and is it a chemical or physical change?
It's a physical.
Why?
Because nothing changed. Nothing in this. It's just paper being destroyed.
Okay. How could we turn it into a chemical reaction?
If we like put it in a chemical, put it in the oven, burn it up in fire,
Okay.
add water, make it, let it salt, or water. You're not even. One more. Okay. Can I do it? I need to get to add one. Sodium.
This weird thingy, and it's making all the stuff in the momentum.
So we added a liquid and a solid.
But then I'm gonna get yelled at if I eat it.
Okay, so you see all these bubbling. It's because of the club soda, and then we also use Mentos. There's still one more in here.
It really didn't do anything, but it kind of.
It was good and sour. Up and you can see like the Mentos stuff coming up.
I didn't eat it.
But nothing bursts or nothing like that.
And that's how you
So just because it doesn't have a big explosion or heat's not given off, does it mean it's not a chemical reaction?
It is a chemical reaction because the Mentos in here are mixing, their chemicals are mixing in with that club soda, and it's a chemical reaction because it created something that measure 2 tablespoons of vinegar into a cup containing 1 teaspoon of baking soda. Make observations about what happens in your science notebook. This is a physical or chemical change. Is this a physical or chemical change? Explain your response. So that's one.
She already did too.
Oh, you did too? Tastes good. So now we are going to do this one.
I know, I accidentally got on my hands. Okay, let's pull that out.
Hold on. That smells like Sprite. It's club water. It's club water. It came in here.
I know, I couldn't hear
That is way too much.
2, right?
Why do we need
already
Oh, yeah, sure.
Okay, you want to do something?
Everybody needs a paper. Yes, I guess if you're all excited.
You are a part of our group.
I think we've got enough.
It was too slow, that's why. We went too slow.
Okay, what's our observation?
No,
nothing. It's busy. Well, the observation was kind of over.
What did you notice the first time they put the baking soda in the cake?
That it got really bubbly.
It got really bubbly?
Yeah.
So what do you think was being produced whenever that change was taking place?
When the vinegar and the baking soda
It was a chemical change.
I was freezing back up when I shook
And what do you think was happening when the baking soda and the vinegar, why do you think those bubbles were created?
Can we add some more? Because
What was being created?
in the vinegar. What is it called? I want to ask.
They were like, no, I don't like
What was the state of matter?
the matter.
A gas was being created, that's right. So we added a solid and a liquid together, and from that, what was created? A gas was created.
So
what-
liquid, and then this is solid.
So do you think, what if we, instead of baking soda kind of looks like what other things?
Cornstarch.
Cornstarch. So do you think,
Flour.
so if we mix vinegar and flour together, do you think we would get,
dough.
do you think we would get gas?
No, it needs like this, like it has like certain stuff in it that like makes it go up. Like it needs like sometimes like it has like these things that automatically go together that like this just cools down, but then like you have like these things that don't mix together, so it just blows up and the pressure just goes up. Right?
Very good. Look.
Now let her do. No, Kate's gonna add the baking soda. I want one. I'm sorry, it's so will Malaya, I guess. Stop bubbling up at the fourth time. So imagine. Hurry up, do it faster. Imagine if it was 6. See, it's.
Now, Shawnee, let me see that vinegar.
I'll help you.
Now she's gonna pour a lot. She's gonna go with it. Overflows. No, I wanted to do it.
That was awesome.
It goes down really fast.
Video. We're gonna go section by section. We're gonna go in alphabetical order, 3 people at a time. So once the first 3 people go, then the next 3 people can go. But what we're gonna do is we're going to create a chemical reaction using baking soda, water, and blueberries. What we're going to do is we're going to mix about a cup of water.
You said blueberries or blackberries?
Blackberries, thank you. A cup of water with 2 tablespoons of baking soda.
This is scary.
And we're going to mix it up. We're going to mix it up. And we're going to use the water and baking soda as our secret message. Right.
Okay.
You're going to take a Q-tip, you're going to dip it in the water, and you're going to write a message on your paper in the back.
It has to be appropriate.
Shawnee's right. It needs to be an appropriate message. So you're going to take the Q-tip, you're going to dip it in the water, knock off the drips, you're going to write a message,